Here is a little mystery before we start. If you throw a ball into the air, its height over time forms a curve. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 6, and our lesson is all about zeros of a polynomial. Before we start, a quick recap. In our last lesson, day 5, we studied Introduction to Polynomials, definition, degree, coefficients, types. If any of that feels unclear, pause here and re-watch day 5 first, because today builds directly on it. By the end of this lesson, student understands that a 0 is the x value that makes the machine output 0, and visually corresponds to the x-intercept. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. If you throw a ball into the air, its height over time forms a curve. The exact moment the ball hits the ground, its height is 0. In mathematics, finding when that height equals 0 is one of the most important things we can calculate. You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? We call this finding that 0 of a polynomial. The name is a bit confusing. A 0 is not the number 0 itself. It is the specific input, the x value, that forces the entire equation to output a 0. Visually, it is the exact spot where the graph slices through the x-axis. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today, finding zeros, graph connection, meaning. In symbols, we write it as if p of a equals 0, then it is a 0 of the polynomial. Every word of that definition matters, so read it slowly. You already know polynomials intro, basic graphing, solving simple equations. This definition simply builds on those familiar ideas. Here is the key formula for zeros of a polynomial. The formula is, if p of a equals 0, then it is a 0 of the polynomial. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Find the 0 of p, x equals 2x, 6. Step 1. Set the output to 0. 2x, 6 equals 0. Step 2. Solve for x, 2x equals 6, which means x equals 3. Conclusion, 3 is the 0. The graph crosses at 3, 0. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. Students confuse the y-intercept with the x-intercept. They plug 0 in for x, which finds where it crosses the vertical axis. We must emphasize, to find a 0, we set the whole equation equal to 0, not just x. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Check if x equals -2 is a 0 of p, x equals x squared, 4. Substitute -2 into the machine. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. p minus 2 equals -2 squared, 4. p minus 2 equals for minus for equals 0. Since the output is 0, -2 is a 0. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits zeros of a polynomial. We explored finding zeros, graph connection, meaning. The one formula to remember is if p of a equals 0, then a is a 0 of the polynomial. Watch out for the common trap we discussed. And remember our goal: student understands that a 0 is the x value that makes the machine output 0, and visually corresponds to the x-intercept. Next lesson, remainder theorem, statement, proof, and worked examples. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.